So we looked at marginal cost, and here we're going to look at marginal revenue. Okay, we talked about the word marginal means derivative of. So we talk about marginal revenue, we're talking about the derivative of the revenue function. Sometimes we will be asked to form our own revenue function. And so let's talk about what revenue is. Revenue is the money realized by a company from the sale of certain units of a certain commodity. So for example, let's say that I sell 5 units, and let's say that the price per unit is $4. The revenue is the amount of money that I would bring in from the sale of those 5 units. So we would take the number of units, which is 5, multiply that by the price per unit, and we would have a revenue of $20. This is not profit, this is just the money that's coming in strictly from the sale of those units. So if we want to form our own revenue function, we will multiply two things together. We multiply the selling price per unit, which is often represented by P, and then we will multiply that by the quantity of units, so the number of units that are sold, which is represented here by X. So our revenue function is price per unit times the number of units. Alright, so here in example 5, we are given that we have some wristwatches, and we're given the demand function. So we're told that the price, so there's that our P, the price function, our demand function, is given by this fraction here, where X represents units of 1,000, which is important, let's underline that, and P is given in dollars. We're asked to first find the revenue function R. This is something that I will ask you to do on an exam, so make sure that you watch how we're about to do this. Notice that we are given P. This is the price per unit. We're not given the revenue function. We're not given the revenue function. So we have to form that ourselves. So remember that the revenue function is R of X is equal to the price times the quantity. Okay, so let's say price times quantity. Let's actually just remove all the parentheses from this, just to say it's price times quantity. I put a little dot to represent that. So R of X, so our revenue function, is equal to price times quantity. So we have P, and all of this is represented by P. So we're going to actually write out what P represents. 44 over 0.05x squared plus 1. And then we're going to multiply all of that, I'll go ahead and put this in parentheses for emphasis, times x. Now we're going to think about x as a fraction, we're going to put this over 1. Since P is represented as a fraction, let's go ahead and represent x as a fraction. When we multiply fractions together, we just multiply across, so it's 44 times x, and then of course this times 1 is just this. So this is our revenue function. Okay, so be careful here. P equals, that's not the revenue function, that's the demand function, that's the price. We have to represent the revenue function by price times the quantity, and quantity here is given by the variable x. Okay, so here's our revenue function. Now that we have the revenue function, now we're going to find the marginal revenue function, which means we need to take the derivative of R. So since we have a fraction, we are going to use the quotient rule for finding derivatives. So it's going to be the denominator, as is, times the derivative of the numerator. Now the numerator is pretty easy, it's just 44x, so we know that the derivative of that would be 44, minus the numerator, as is, which is 44x, times the derivative of the denominator. Okay, so what's the derivative of the denominator here? We're going to use our power rule. So 2 times 0.05 would be 0.10. Subtract 1 from the exponent, I just get x to the power of 1. We have plus 1, but we know the derivative of a constant is 0, so we end up with just 0.01 times x. Okay, and all of that is over our denominator, as is, but we're supposed to take it and square it. Okay, so this is the quotient rule. We have the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Now let's simplify this a little bit. All right, I'm going to go ahead and distribute in the 44 into the first parentheses. I get 2.2x squared. You could just put that into your calculator. And then 1 times 44, of course, is 44. And here I'm going to distribute, or really don't need to distribute, just multiply 44x times 0.10x. You can put that into your calculator if you wish. I get minus, negative times a positive is a negative, negative 4.4, and then we have x times x, which gives us x squared, all over that denominator squared. Okay, and the last thing I want to do, if I want to simplify a little bit more, really the level of simplification we said is completely up to you. In this case, in part C, we're going to actually have to do a computation, so I'm going to simplify a little bit more. I have two terms in the numerator that are x squared, so I'm going to go ahead and combine those. 2.2 and then minus 4.4. So notice that the larger number is negative, so I'm going to subtract those, and I get a negative number because the larger of those two numbers is negative. So that's a negative 2.2x squared plus 44 all over that denominator squared. Okay, and this is my simplified form of that marginal revenue function. Okay. Now the last part that we're asked to find is to compute r prime of 6. So that means that we're going to put 6 into our marginal revenue function. Now, before we do that, let's just interpret what we're about to find. 6 represents x, which is units in thousands. Okay, so what we're really talking about here is we have 6,000 units. Since x is already in thousands, then we're just going to put in a 6. We can think about this as kind of like our current level of production. We want to know if we should increase production from 6,000 units to the next unit, so 7,000 units. So should we increase production, what happens to the revenue? How does that affect the revenue? So should we go from 6,000 units to 7,000 units? Should we increase our production? I want to know how that affects the revenue if we do increase our production from 6,000 to 7,000 units. So let's put this into our revenue function, marginal revenue function. So I'm going to have negative 2.2 times 6 squared plus 44 all over, we have our denominator, which is 0.05 x squared, so 6 squared, plus 1, and then all of that raised to the power of 2. I'm going to do something just to kind of clarify a little bit in our denominator that it's all of this. I'm going to use brackets instead of parentheses here. It's all of this being squared. Okay, I know up here we had the parentheses surrounding that, but since I put a parentheses around the 6, just want to make this extra clear that these brackets are telling me, these parentheses here, these grouping symbols are telling me to square everything that's inside of those brackets. Okay, so when I put the top part into my calculator, I get negative 35.2. When I put all of this into my calculator and then I square it, I get 7.84. So I get something that looks like this, negative 4.489795918, and so on. And the directions tell me to round to the nearest 3 decimal places. So I'm going to go out 1, 2, 3, and I'm going to focus on this number here. And since this number is larger than 4, so remember if it's 5 or higher, then I'm going to round up. Now rounding up means that I'm going to round this to a 10, which really rounds me up to a 90. Okay, so I get negative 4.490. Now this is represented by dollars, so what this is telling me is that the revenue is decreasing. If I increase my let's see here. If we increase from 6,000 to 7,000 units, this is telling me that my revenue will decrease by $4.49 per unit. Okay, here in this example, and the last example was example 5, and now I'm at example 3, so we're just going to disregard the numbering here. Here we have a problem where we're talking about an air service, and it realizes a monthly revenue by the following function. So we're actually given the revenue function this time. We don't have to come up with it on our own. The output is measured in dollars, and the input, the X value, is price charged per passenger in dollars. We have to find first the marginal revenue function, which all that means, we said, is marginal means derivative of, so we're asked to find the derivative of the revenue function. This one's pretty straightforward. We're just going to take each term and we're going to use the rules that we talked about in chapter 3. 4,800 would be the derivative of that first term. We're going to just take that constant from in front of x. Then here we're going to use the power rule. 2 times 120 would be negative 240. It's negative because of that negative sign there. And we're going to reduce the power by 1, so I get x. Pretty easy there. Pretty easy derivative as far as derivatives go. Now we're asked to find, to compute the following values. R prime of 19, 20, and 21. Alright, so let's do that. R prime of 19, if I put 19 in place of x in my marginal revenue function, I get 240. Okay. If I plug in a 20 into my marginal revenue function, I end up getting 0. And if we plug in 21 into our marginal revenue function, we end up getting out negative 240. Remember that the output is a value given in dollars. And after we determine those values, then the last question is what we want to answer. Part C says, based on those results, what price should the airline charge in order to maximize their revenue? So we want to go back and kind of interpret these results a little bit further. Okay, so what price should the airline charge in order to maximize the revenue? So let's go back and do some interpreting, use our interpretation skills here. Remember that the value that's gone into the revenue, the marginal revenue function is the current level. And we're going to say, in this example, this represents price, ticket price. So this is the current ticket price. We want to know if we increase that ticket price by $1. In other words, this first test is saying if we charge $20, so we're currently charging $19. If we up the price by $1 and then charge $20, then what will be the effect on revenue? Well, we're talking about a derivative here, which we can think about this once again as kind of like a slope. So let's think about this as 240 over 1. I'm going to scoot this down. Okay, so if we increase the ticket price, which is kind of like our X value here, by $1, then what happens to the revenue? Well, the revenue actually will go up by $240. Sounds like a pretty good deal. That's a pretty big increase in revenue. So that sounds pretty good. Let's go to the next one. The next one says that if you are currently charging $20, should you increase your ticket price by $1? In other words, should you start charging $21 for a ticket? Well, this would imply that your revenue would not increase or decrease. It would not affect your revenue at all. So it doesn't seem like it would be worth it there. If you're currently charging $21 and you want to up your price by $1, by 1 unit, then you will be charging $22. And how does that affect your revenue? Well, in this case, it looks like the revenue will be affected in a negative way. The revenue is going to start going down. Okay, maybe people think that's just too much to pay for a ticket and they quit buying tickets. So this impacts your revenue in a negative way. So how much should we charge? Well, I would say that if we're currently charging $19, we should start charging $20 so that our revenue will have the most positive impact of $240. So I'm going to say that we should charge, based on that information, we should charge $20 a ticket. Okay, so that has the most positive impact, when we look back at our numbers, the most positive impact on the revenue. Okay, here it says example 6, we're looking at a weekly demand function for some televisions. And the demand function is given right here by price. P represents the price per unit, so we have the price relating to quantity, so this is our demand function. Notice that this is not our revenue function. This is just the demand function. So there's our demand. It says the weekly total cost function is given here. So this is our cost function. So we're given the demand function and the cost function. So we are asked first to find two things. We're asked to find the revenue function. Okay, let's see if we can remember what revenue is represented by. So remember, the revenue is the money that's coming in. So how do we say we find the revenue? Well, the revenue function is the price, the unit price, times the number of units that we sell. So this is not the revenue function we're given. We're given the demand, we're given the price. We're going to multiply that through by x. This is actually pretty nice and easy. I'm just going to multiply each of those terms by x. So x times the demand function here, 540 minus 0.01x. So we're going to multiply x in. I'm going to distribute it. So we get our revenue function. We get 540x minus 0.1 times x squared. Okay, so not too bad. I will ask you to do that on the exam, so please keep that in mind as to how to find that revenue function. If I give you the demand function, you need to multiply through by x. We're also asked to find the profit function. Okay, another thing that I will ask you to do on the exam. The profit function, remember, is revenue minus cost. So it's the money that's coming in minus the money that's going out. Okay, so profit. So now we know the revenue function. We just found it. That's 540x minus 0.1 x squared. We're going to subtract off the cost. Now here's the important part that a lot of people forget and lose points on the exam. Make sure that you distribute the negative into the entire cost function. So I'm going to put parentheses around that just for emphasis, just to remember that we are going to distribute. Okay, so this negative changes the signs of everything in the cost function. Okay, so put a few stars by this in your notes as you're working through it, and make sure that you do that. You will be asked to do that on the exam. So I'm going to go ahead and distribute the negative. I get negative point, I got 5 zeros there. And this is going to become positive, so that's important. This becomes negative 250x. This becomes negative 87,000. Okay, now I'm going to simplify because we're going to have to do something with this in just a minute. I'm going to combine the like terms. I'm going to start with the x cubed term, and I'm going to go ahead and just put that out front. I'm going to combine the x squared terms. I have this term here, and I have this term here. Combine that in your calculator there, you end up getting a negative value since this number is larger, negative 0.08 x squared. So I got these three. Now I'm going to combine my x terms. I get a positive 290x and then a negative 87,000. Okay, so this is the profit function. So I distribute the negative into the cost function, changing all the signs, combine my like terms, and then I have my profit function. Alright, so now we have kind of the three big things. We have a cost function, we have revenue, and we have profit. Part B asks us to find the marginal cost, the marginal revenue, and the marginal profit functions. So we're going to take the derivative of each one of these. I'm going to go ahead and start with cost, since that's at the top there. And this is really nice because this is just straight up power rule for each one of these. So we're going to take the 3 and multiply it times the constant that's out front. Reduce the exponent by 1. We're going to do the same thing here. And the same thing here. That's a pretty easy one. We know that's just 250. The derivative of 87,000, since that's a constant, is 0, so we are done with the marginal cost. Okay, so marginal cost, taking the derivative of that cost function. All right, so now we're going to find marginal revenue. Even easier, there's only 2 terms. So that turns out to be 540, excuse me, not the x, but just 540 for that first term. For the next term, we use the power rule, so 2 times 0.1, and then reduce the exponent by 1. All right, and the last part asks us to find the marginal profit function. So we're going to use the power rule for each one of these terms. Alright, so pretty straightforward there, power rule, and then of course the last term of that profit function is a constant, so I don't have to take the derivative of that, we know it's 0. Well, we know the derivative of that is 0, so I don't have to write anything down. Alright, so those are marginal profit, cost, and revenue functions. Now we're asked to compute the following values. So we want to know what happens when you plug 2300 into each one of those functions. So keep in mind that what we're actually doing here is we are saying that if we are currently at a level of production of 2300 units, so let's write that down. So this is our current level of production. We want to know, should we go ahead and increase to that next unit? Should we increase production? Is it going to be worth it? Is it going to increase our profit? Okay, so we're going to find out how that affects the cost, the revenue, and the profit if we increase production by 1 unit. So we're just going to take each one of those functions, scroll down a little bit, and we're going to plug in 2300. So my marginal cost turns out to be $269.09. So you might think, okay, well, if that's going to increase cost, so if we think about that as slope, that means the cost is going up this much if we increase by 1 unit. Well, that might not be terrible. It depends on how much money that we're bringing in. Let's say that we bring in $1,000. If it costs us $200, but we make $1,000, then we profited about $800. So we want to know how this also would affect the money that we bring in. So how does this affect the revenue? So let's see, 540 minus 0.2 times 2300, and it looks like we get 80. So in this case, I would say that if the revenue is only going to increase by $80 for that next 1 unit, and the cost is going to increase by $269, it doesn't look like it's going to be very profitable. The money going out is more than the money that's coming in. So I'm not making enough money to make the cost reasonable. Right, so it would stand to reason then, with those 2 things in mind, that the marginal profit would be something negative. That would tell me that I'm losing money in this case. So let's see what the marginal profit turns out to be. Okay, we throw all that into our calculator, get negative $189.09, which is exactly what I anticipated, because the money going out is $269 and I'm only bringing in $80. So it looks like I'm losing. My profit is actually going down if I increase my production by that one unit. So should production be increased? And I would say that the answer is no here. We should not go from 2300 to 23 and 1 unit because the marginal cost is more than that marginal revenue. And furthermore, the profit function is negative, which means the profit would be decreasing if we increase the production.